Welcome back. In this video lecture, we will going to see about finite automata with output. Finite automata with output classifies into two types: mealy emission and Moore emission. Both mealy and Moore emission defined by six tuples. The six tuples same for the mealy and Moore emission. Here is the six tuples observation or the de- definition depth. Okay, here is a q is a finite set of the tuples. Okay, and finite set of non-empty set of input alphabets, set of output alphabet, transition function, output function, initial state, etc. Let's comes to the mealy emission. It is a simple diagram or simple structure of the mealy emission. Okay, simple mealy emission. In the final state of finite automata with output, here another path will came when compared to finite automata without output. Here the output we have to mention the output within the finite automata. Okay, in the mealy emission the output symbol must be with the input symbol only. Okay, here starting state A which takes the input 1 and goes to the A only, then it produces the output as B. Okay, here the output symbol must to be present with the input symbol. That is the basic and important condition for the mealy emission. Well, compared to the Moore emission, the output symbol presents within the state only. Okay, within the state only. It's the starting state A which takes the input as 1 and goes to the same state A only, then produces the output as A. Here the output symbol, we have to mention that output symbol within the state only. Okay, this is the main difference between the Moore and mealy emission, and it is the basic and important rule. Okay, let's go to an example. Construct a mealy emission that produces the ones complement of any binary input string. Binary input string. Let us take an example of the binary string 1011. We have already know about the ones complement is nothing but changing the ones to 0 and zeros to 1. So here is the ones complement of the above binary digit. Okay, now we have to construct the mealy emission. Starting state A which takes the input as 1 and produces the 0. Okay, I have already said that the ones complement is nothing but the changing ones to 0. So when we take the input as 1, then it produces the 0 as output. Okay, when it takes the 0 as input, then it produces the 1 as output. So hence it is the mealy emission that produces the one complement of any binary input string. Okay, let us see another example. Construct a mealy emission that prints A whenever the sequence 01 is encountered in any input binary string. Okay, whatever it is the string, the sequence, if the string, if the string consists of the sequence of the 01, okay, then it means the output as A. Okay, let us see with the medium emission diagram. The starting state A, this takes the input as 0. Okay, we have to design first for the 01 sequence. 0 it goes to B and it takes the 1 as input and goes to C. Okay, whenever the 01 is encountered or 01 sequence is present within the string, then we have to print the output as a. So we have to return the A within the input symbols in mealy emission. So whenever the 01 is encountered, then it prints the A. Whenever if it will take the 1 as input, it goes to the same state only and it will produce the B, prints the B only. Okay, whatever it is, whenever the sequence 01 is encountered, it will print the A. Okay, it is a mealy emission of prints the A of the sequence 01 is encountered. Let us see the another example. Construct a Moore emission that prints A whenever the sequence 01 is encountered. Same as the previous question, but in the previous question we have constructed the mealy emission. Now we will construct the Moore emission. Okay, same as it is the above problem, but here we have to mention the output symbol within the states only. That is the difference between the both meal emission and the mode emission. Okay, same as it is, we return the output function within the state only. Okay, here we return the within the input symbol. It is the main difference between the mealy and mode emission. Thank you.